Hey, what is good, you guys? I am Jaydeep and welcome back to JDL. So, in continuation with the series on data types in Python, the next one which we are going to look at are tuples. So, what are tuples? The short and the most common answer is they are immutable lists. But what I want you to pay special attention is to the word immutable. That is where true power of tuple lies. So the idea behind any programming language is to use, or any programming is in general, to use the right tools for the right job. Without that, you're not writing optimized code or good code. So a practical use case of tuples is scenarios where the data which is going to be stored is not going to change. Otherwise, you could just use lists, but then that would offer degraded performance. So where could you find use case of tuples? If I have to think of something off the top of my head, say you're working on a system which stores engineering data, engineering college data, where in India at the time of this tutorial there are only 4 years: first year, second year, third year, fourth year, and each student belongs to one of these years. So tuples can be easily used to store this data. What that does is gives you better performance and better memory management, because this is fixed data, and at the time of making of this tutorial I don't think that has changed or will change in the foreseeable future. So in terms of creation and accessing the elements, tuples are very similar to lists. There is no difference at all. So the simplest way to create a tuple is initialize the data within a round bracket. That is the only difference. If you do a type of A, this is now a tuple. In lists, we did something like this. That is, we used square brackets. Now, accessing the elements, as I said, remains similar. You can use 0, -1 index. Then they also support slicing. So if you do something like this to this, then it oh well, -1 to 1 with an index of -1, because I want to go from right to left. So it remains similar. There is no change in this. Now, as I said, they're immutable. So suppose you try to change one of these elements, then you would have an error. So if I do an A of 0 is equal to 100, then I would get an error that tuple does not support item assignment, hence the immutability. So just like the list API, the tuple API also comes with some inbuilt methods which you can use to make your life easy. Say min of A, or a max of A, or the length of A. So these are standard methods which come in as part of the tuple API as well. The sorted is not available for obvious reasons, that you cannot change this. This has to be this data has to remain as it is. So if you do a sorted of A, you can still do it, but if you see, this is not in place. That is, the tuple has remained changed, and also the data which has come back is a list. So that is something which needs to be kept in mind. There's also something called if you want to search within, or if you want to search if an element exists in a tuple, you can simply do and use the in operator. So let me take, what is it, 22 in A, it will return a true. If I do 777 in A, it will return a false, because that is not contained. So these are certain methods which are available for a complete list. You can do a help of tuple that would give you a complete list of methods which are available as part of the tuple API. Okay, so let us talk about an essential no-no use where tuple should not be used like this. Now, if you see this tuple, now this contains a list which is a mutable data at the end. So this is a strict no-no. You should never do this. This tuple has no integrity, and this is not how tuples are meant to be used. If I do visual execution of this and I do a next, if you see, the fourth element is a mutable list, and if you do next, this data changes. So this is a strict no-no. This is not how tuples are meant to be used. So this. Okay, let us talk about tuple unpacking and the star operator. Now, tuple unpacking is pretty powerful, and there's a lot of use cases which you will find in your day-to-day life when you start actually using Python. So what I mean by tuple unpacking. Now, this D is a pretty big tuple. I'll just create a new one, A, which has 3 elements inside it. And now you want to individually access these elements. So what you can do very easily in Python is access it, assign these elements individually using the tuple unpacking. Tuple unpacking is equal to A. Now B, C, and E will have these individual elements. So this is called as tuple unpacking. So this is pretty powerful, and you will have a lot of use cases for this, wherein you are passing user arguments, or you're capturing user arguments. So that kind of scenarios where you don't know the number of the parameters which are coming in, it'll be pretty useful. So that is tuple unpacking in a nutshell, and the star is just an extension of tuple unpacking. Now A was pretty straightforward. It had three elements, and you knew them beforehand. But consider a tuple like D, which has 10 elements, and you don't want to use all these elements, but you just want to use the first two, or the last two, or the first and the last. So what you would do in that case? Then you would use the star operator. And how would you do that? So A, comma B, comma star of C is equal to D. So A, B, star of C, and let us assign D back to this, and let's see what happens. So A would contain the first element, B would contain the second, and C would be a list of all the remaining ones. And now if you do A, comma star of B, comma C is equal to D, and A would be the first, C would be the last, and B would be the middle elements from 3 to 9. And if we do a star of A, comma B, comma C is equal to D, then B would be the second last, C would be the last, and A would be the first 8 elements. So this is tuple unpacking and the star operator. Okay, so moving on, a very good use case and practical scenarios of tuples is using them as records. So a record can be absolutely anything. You can store absolutely any data within them. So suppose I'm using tuples to store travel history. So these are just 3 travel records. So let's make them one. This is a Jaideep, and he comes from India, and he wants to travel to the UK. And second person is Ram, and he also comes from India, and he wants to travel to the US. The next person is say 3. The next person is say 3. His name is Chad, and he comes from Holland, and yeah, he wants to travel to say India. All right. Let's place this comma. So now S is a how do you say? It contains 3 tuples, and each tuple is a record which stores travel history. Now tuples are a very good use case for such a scenario, and you can easily access. So suppose you want to access the travel history of only Jaideep, then what you can do is A, comma B, comma C, comma is equal to S. Now A would have the travel history of Jaideep. So tuple unpacking again comes into place here. B would have the travel history of Ram. So continuing with the tuples as a records thing, so how would you use tuples? So just this is another use case where let's see. I have a tuple which stores. So let's say this is a bank record, and these are the people who have applied for something or the other in the bank, and these are the documents you have submitted. So this is a very good use case of how you can use tuple as a record. And then the concept of tuple unpacking, which we learned, can easily help us to dig out these records. So now you want to get a list of all the people who have applied for one or the other product. Now the product is not listed. We'll move on to that in a little bit. So I just want the names of each and every person who has applied for one or the other product. So what I would do is x comma underscore. Now why underscore is because I don't want to I don't want this second element. I have no use for this. I don't intend to use this. If I wanted to use this, I would do something like this in an unpacking, but I don't want to use this. So underscore is a special symbol which is provided in Python. 1 2 3 4 print x. So this would give me the list of names who have applied for one or the other product. Now if you don't want the list of names but a list of documents what each of them has submitted, would just reverse this, comma x ns 2 3 4 print. So this gives a list. So iterating tuples via tuple unpacking is very easy, and it comes in very handy, trust me. Now suppose we'll modify this tuple, and not modify, so just create a new tuple which has more data. As I said, let us assume that this is a bank data, and now what I've done is I've added a product which they have applied for. Okay, so I've applied, so Jaideep has applied for a loan, Ram has applied for a savings account, Sita has applied for a demat. Now what if we want to get the only the list of products which each person has applied? It can be very easily guessed by this comma this comma x a ns 1 2 3 4, 1 2 3 4 print, and yeah, so this is it. So this gives me a list. Now I have to do double underscore, but do I really need to do double underscore? We just saw the star operator. So what you can do is star a comma b in s 1 2 3 4 and print, and that would give me the same thing. Also, if we now print, or let's do this again, and 1 2 3 4 print a, and this gives me the remaining data. So this is how tuples can work effectively as records, and tuple unpacking helps us to easily read data. So this is pretty powerful, and this has a lot of use case when you actually start doing stuff. So that is it for this video, guys. This was all about tuples in Python. I have listed down a summary of this video. You might want to pause and take a look at it. Important takeaways are tuples are immutable. Use them. An essential aspect of programming is using the right tools for the right job. Tuples are best suited for fixed line data. They offer you visible performance. And the other points are tuple packing and unpacking. This is something new. You might want to take a look at that as well. So that is it for this video, guys. Again, thank you for watching.